During the manufacturing of lightweight composite structural components, it is necessary to position plies of dry, wet, or pre-preg fabrics accurately on a tool surface or on top of the preceding plies during the lamination of the part. Accuracy in ply placement, as well as the quality assurance issues regarding the correct ply layup sequence and the correct orientation of the ply when installed, are very important factors in the manufacture of high-cost, high-performance composite components. One of the difficulties in building composite laminated parts is locating the laminate precisely into the tool when you cannot see a reference line on the tool surface. In the past, it was common to build solid templates that could be placed into the tool that provided guidance or reference lines and cutouts to assist the laminator in placing plies in their correct locations. Unfortunately, solid templates inherently have problems. They are costly to manufacture. They're difficult to build and use on complicated parts. Solid templates are difficult to locate and reliably hold in place while being used without some type of locating system. Building the locating system also adds complexity and cost to a customer's project. Solid templates are difficult and costly to modify when the customer requests changes, updates, or revisions to be made to the original part. And the templates become damaged through usage or even during storage. In the modern manufacturing environment, visual ply placement aids are required to assist the operator to perform the ply sequence and ply placement tasks correctly in all but the most simple of composite parts. The visual aid system is used to display together on a single computer screen a live video image of the real world that the operator is interacting with and a computer-generated image of the part structure with the virtual composite ply already in place. By viewing the compound image, the operator can accurately align the actual ply with its image on the monitor as located and drawn by the software. The data for the computer-generated drawing of the plies that are displayed correctly in place originate from the part's original computer-aided design file. The visual aid system consists of a digital camera, a sensor bar, 2 probes, a monitor, coordinate measuring software incorporated in a desktop computer, and a wireless calibration probe. The digital camera is a simple unit with the ability to zoom in and zoom out with 2 times magnification. There are 2 probes which are attached to the camera and to the mold. One is a T-shaped probe, the other is a star-shaped probe. Both have light-emitting diodes or LEDs built into their bodies. The sensor bar is able to see the LEDs in the probes via infrared sensors in windows that are found at either end of the sensor and in the middle of the sensor. A wireless calibration probe is required to locate the mold in space. The computer contains specially developed software that drives the augmented reality and projects the outline of the virtual ply to be laid into or onto the real-time picture of the mold being displayed on the monitor. Aligning the visual aid system prior to use in lamination is a quick process. The technician begins the process by installing alignment pins into the tool in their designated positions and then secures the part sensor anywhere onto the tool surface. The next step is to enter the tool alignment pin coordinates into the software using the customer project manual and then use the wireless calibration probe to physically locate each alignment pin. This alignment process allows the overhead sensor bar to locate the mold in space. The position and direction of the digital camera in space can be changed at any time. The computer continuously and automatically updates the camera's position in the software using the sensor's probes, thus enabling accurate positioning of the computer-drawn image on the monitor as the live video image changes. Here's an example of placing a laminate ply into a part in its exact sequence and exact location using the visual aid system. The technician accesses the correct ply in the laminate sequence using the keypad and the mouse. The data from the computer-generated drawing or CAD file of the ply is displayed along with its fabric orientation and the correct ply location in the part shown on the monitor screen, along with the mold and in-process lamination showing in the background from the camera image. The highlighted area on the screen is used by the technician to accurately place the ply, in this example a pre-preg doubler, in its desired location. Once the ply is confirmed to be in the correct position, the technician fully installs the ply and then uses the ply projection as a final placement check before moving on to the next laminate in the sequence. The system software records the entire installation and final measurements into the parts record for quality assurance usage. The use of the visual ply placement system allows the engineering and manufacture of very complicated parts that are as light as possible while still meeting all the in-service strength requirements needed by the customer. The system eliminates the need for solid templates and all the additional costs and maintenance issues associated with their use. Visual ply placement aids the technician in installing the correct ply laminate at the correct time, ensuring the correct fabric direction, ensuring its proper location, with a visual measurement confirmation assuring the technician's confidence and success at every step in the process. Using the system's built-in quality assurance feature of recording the entire laminating process and saving that record for later review by an inspector provides the much-needed confidence that under the part, the paint, the primer, and layers of fabric, all the laminated plies, the core materials, and the mounting reinforcements are in their exact location every time.